RAG. So, classic RAG that we've learned a lot of only reads text, but most not real knowledge that we see day to day lives in charts, slides, screenshots, and videos. And the exact number we might need to answer a specific question might only be in pixels and not written down anywhere. Multimodal RAG closes that gap. You ask a question in plain English, and then the system is able to pull back the right image, and a visual language model, i.e., a VLM, reads the answer straight off it. And I want to walk through how that works and show what it looked like when we built one end to end. So, just to orientate ourselves, I'll give you kind of two diagrams explaining different things. So, the first one is kind of the core idea of what we did. So, the whole approach rests on one insight that the VLM plays two different roles. It plays its first role at ingestion, where it's a parser, so it looks at each chart and writes a structured caption, which can be embedded and searched. And so we can see that here, where it's able to ingest the image and provide captions in chunks that can be embedded and then used in regular RAG. And then at query time, it's a reader. So once retrieval finds the right image, you hand it the real pixels of that exact image, and the VLM is able to read those exact values. And so the reason that this split happens is because embedding models are primarily text only, but chat models are multimodal, and the component that can see an image can't index it, and the one that indexes it can't see it, and so you get this mismatch. And the single mismatch is the reason that multimodal retrieval is hard, and it's kind of the thread running through everything that we built. And so the next piece of what we looked into was actually retrieving across different modalities. So we're essentially trying to answer the question, how does a text query find an image? So we went through three different strategies. The first one, A, where we caption the images, and then it's ordinary RAG that we're used to. Simple, but you're limited to what that caption it captures, essentially. And so you might not get a full picture, and it's slightly a lossy summary, you could describe it as. The second one is strategy B, which uses a unified model like Clip that embeds text and pixels into one space. So a query matches a picture directly, but Clip has this famous flaw of the modality gap. So text vectors and image vectors cluster apart, even though they might be sharing like the same kind of semantic meaning. And so a text query drifts towards any text over the right image. And so we saw this throughout what we built, and we could clearly see the modality gap at play, with also giving poor recalls for the kinds of queries we were asking. And then the last one is we keep separate stores and then fuse them by rank with reciprocal rank fusion. So each modality, so that's text and image, uses its best embedder, and you merge by position, not a raw score. So you can never compare raw scores based off different embedders because they really just don't relate to each other. And so using reciprocal rank fusion, you go away with that and purely go off rank. And because this and then this strategy was probably the most robust, and yeah, really showed good results. And we can see those here in the numbers that we got throughout our workbook. But let's jump to the actual workbook. We went through. So in the first kind of section, we went through parsing and then the cross-modal retrieval. Yeah, so here we have our setup. Here we describe the VLM doing its two different jobs of parsing but also understanding at query time. We have our data sets here. We have images as well as text, and so we read those in. You can see that there. And then we went through some each chart kind of and define, and here you can see a demo question, yeah, for each kind of chart and what it would answer. And here we see the VLM as a parser and a chunker. So this is the strategy A, where we jump into building our captions and text embeddings, and then strategy B that we went through, and then lastly strategy C. I think we then went and asked a few questions here of the kind of queries where I would expect only a image to be able to answer. So like a visual phrasing one, so a pie chart showing how cloud costs break down. So we would expect kind of this to be used. And then what share of a cloud spend goes to compute, and it was based off kind of this text that we would read in. And so comparing the different strategies and the chunks that they bought into and kind of ranked in terms of k equals 3, and we saw that here. So we saw that strategy A, that because of the small corpus and how well the caption was, it matched the factual phrasing pretty well. And then with strategy C, we saw that it actually just pulled in text the entire time and no images whatsoever. So this is again the modality gap that happens when using the kind of strategy B, where both the images and the text exist in the same space, and so there's always this kind of favoring towards text just because the match is so much better. And then in strategy C, we saw that it brought in both images and text docs, and they both answered and both the chunks had answers to the question, so that was good to see. And then we moved on to video. So this the same kind of pipeline extended nicely to video, and here I'll quickly move through this and show some important things. So I guess this is an important piece here. Time-stamped transcript and a sequence of keyframes are kind of captured from the video, and they're windowed into chunks that know what was said and what was on the screen. And we reuse the same kind of retrieval methods and strategies that we described before. And now the answer comes back with clear timestamps. And so you can see that here where we have our timestamps and what was on screen. And then here again, we're able to answer questions neatly and provide timestamps for our video frame. I guess a big call out is when you do this kind of frame breakdown, there's the possibility that there can be big frame explosions. So at 30 minutes, for 30 minutes at 30 frames per second, you can get over 54,000 frames, and so you wouldn't index them all. And so you kind of have to, come up with smart ways to capture the frames, kind of reducing duplicates and so on. I guess in the example that we then went and did, we asked questions again of ones that would only live in text documents and those that lived in charts. And again, consistently we saw that for the strategy B, the recall was poorer compared to strategy in A and C. And I think A works so well because, the captions were good. But if that wasn't the case, maybe we would see this actually poorer than expected. But all in all, the VLM does two jobs. It's an ingestion parser and a query time reader. Unified, and another important piece that I learned was unified embeddings alone are fragile because of the modality gap. Caption, first off, you want to caption upfront or fuse by rank. And then thirdly, I guess retrieval finds the chart and generation reads that number off it, which we saw with the VLM. And that's why we want to keep the real pixels kind of attached to the captions and not just get rid of them once we create captions, because the captions can be lossy. And all in all, that's multimodal RAG. So thanks for watching.